Hello friends and students. There have been a lot of requests for me to record and upload lectures in linear algebra. So I begin with linear algebra and I plan to go through the entire syllabus in order. Whether you are a student in degree or whether you are doing your engineering course or whether you want to brush up your fundamentals of linear algebra or you're taking up your UPSC examination where linear algebra happens to be one of the papers. This is the right place where I will be explaining the concepts in detail and we will be going in order. So today in this first lecture of linear algebra, I'll be dealing with what a linear equation is. What is a system of linear equations? The solution of a linear equation and the solution set. The solution of a two-variable linear equation, and we'll also discuss about consistency and inconsistent. So when is a system of linear equations consistent, or when are the system of linear equations inconsistent? So we shall be going through all of them in this lecture today. Now what is a linear equation? Let us consider variables x1, x2 up to xn. Any equation which is of the form a1 x1 plus a2 x2 plus so on plus an xn equal to b is referred to as a linear equation, where a1, a2 and so on up to an are the coefficients. So they are the coefficients of x1, x2 up to xn respectively. And what about these values? These values a1 to an and b are either real or can be complex. So they are either real or complex. So this is how we define a linear equation. Now what is a system of linear equation? A system of linear equation is nothing but a collection of one or more linear equations involving the same number of variables. Now let me consider an equation x1 plus 2x2 plus 5x3 is equal to 10, x1 plus 5 x3 is equal to 6, and x2 plus x3 is equal to 7. So this happens to be a system of linear equations where you have three variables, right? So the variables are x1, x2 and x3. So this forms a system of linear equations. Now let's discuss about the solution. So what do we mean by the solution of a linear equation? The solution of a system of linear equation is nothing but a list of numbers. So let me say that the numbers are s1, s2 up to sn. Now if I substitute these numbers s1, s2 and so on up to sn for x1, x2 up to xn, right? So I'll be substituting s1 in place of x1. And instead of x2, I write s2 and so on. So these numbers s1 to sn are substituted in place of the variables x1, x2 up to xn. So when I substitute the values s1 to sn in place of x1, x2 to xn, in place of these variables, what happens? The LHS becomes equal to RHS, right? So it makes each of these equation a true statement. A true statement meaning that the LHS will be equal to RHS. So let's assume that I have three values s1, s2 and s3. So I put s1 in place of x1, s2 in place of x2 and s3 in place of x3. Then in that case, when I sum up the LHS, it would be equal to 10. So 10 LHS would be equal to RHS. When I substitute these two values here in the second equation, because this system of linear equations contain three equations. You have three equations, isn't it? So again, when I substitute s1 and s3 here, I would get LHS equal to RHS. The LHS will also be equal to 6. And similarly, when I substitute s2 and s3 here, I would get the LHS equal to 7. So then this set of numbers s1, s2, s3 is referred to as the solution of the linear equation. Now the question is, can you have only one solution? You may have many solutions. I may have another set of numbers. say S4, S5, S6, and when I substitute these values in x1, x2, x3, even then if the LHS becomes equal to RHS, then even these three numbers would be the solution of the set of linear equation. So therefore, when I talk about the solution, you may not have one solution, but you may have many solutions. So when we have many solutions, you have a set of solutions. So the set of all possible solution is called as the solution set of the linear equation. So if I have many such solutions, so the entire set of all possible solutions is called as the solution set. So we have defined what a solution set is. Now let us consider a two-variable linear equation, and let us try to understand what are all the different possible solutions we could get, and is there a possibility where the solution does not arise or we do not get any solution. So let's consider that specific case where we have a two-variable linear equation. Let me consider the first set of linear equation, x1 minus 2x2 equals minus 1 minus x1 plus 3x2 is equal to 3. Now let us see if I can find the value of x1 and x2. Let us see if I can find the solution of this set of linear equation, a two-variable linear equation. If I add these two, x1 gets cancelled, so I get x2 is equal to 2. Substitute the value of x2 in any one of the equation. So x2 is 2. So when I substitute the value of x2 in any one of the equation, I would get minus x1 plus 6 equals 3. So x1 equals 3. So one of the solution happens to be x1 comma x2, which is 3 comma 2. Can I visualize this solution of the set of linear equations? Yes, I can. So let us consider two axes. This is x1 and this is x2. Now each of them represent a straight line. The line L1. So if I put x2 equal to 0, I get x1 equal to minus 1. And if I put x1 equal to 0, we get x2 equal to 1 by 2. So these are the points which lie on the line L1. So therefore, I have x1 is 0, x2 is half. So if this is 1, 2, here I have 1, 2. So x1 is 0, x2 is half. So this is 0 comma. So if this is point A and point B, so this happens to be point B here. And next x2 is 0, x1 is minus 1. So this is minus 1 comma 0. So this is point A. So the line passes through these 2 points. I join these 2 points and I extend it. So this is L1, which corresponds to the first equation x1 minus 2x2 equal to minus 1. Now similarly, let me find 2 points on the line L2 which touch the axis x1 and x2. If I put x2 equal to 0 in the second equation, I get x1 equals minus 3. Similarly, if I put x1 equal to 0 in the second equation, I get x2 equals 1. So let this be point C and point D here. So when x2 is 0, and x3 is minus 3, I get this point minus 3 comma 0, which is point C. And then you have x1 is 0. So x1 is 0 and x2 is 1. So this is the point D. So 0 comma 1. Now let me join these 2 points and let me extend it. So this is L2. Now we realize that L1 and L2 will intersect at a given point and that point is nothing but 3, 2. So x1 is 3 and x2 is 2. So what I have done is not to scale. So you can actually plot this on a graph sheet, and you will observe that these two lines will intersect at a point, and that point will represent the solution of the given set of linear equations, two variable linear equation. So in the first case, case 1, there was a solution. That means the solution was 3, 2. One solution. Or we can say that you only have a unique solution. Why is it that we only have one solution? So since these two lines will only intersect at one given point, there is only one solution, and this is referred to as the unique solution. Now let's consider the next case. x1 minus 2 x2 equals minus 1, and minus x1 plus 2x2 equals 3. Now let me find the points wherein the line L1 and L2 would pass. So I have x1 and x2. So here, if I put x1 equal to 0, I find that x2 is equal to 1 by 2. Now similarly, if I put x2 equal to 0, x1 is minus 1. So this is for the first linear equation. Similarly, if I put x1 equal to 0, I get x2 equal to 3 by 2. If I put x2 equal to 0, I get x1 equals minus 3. So this is for L2. So now let me mark these points. So x1 0, x2 is half. So this is 0, half. x2 0, x1 is minus 1. So this is minus 1, 0. So I join these 2 points. When I join these 2 points, I get L1. Now observe the next one. x1 0, x2 is 3 by 2. So this is the other point. x1 is 0 and 3 by 2. And then I have the other point. x2 is 0, x1 is minus 3. Minus 3, 0. Again, I join these 2 points. Now, when I join these 2 points, I observe that these 2 lines are parallel. Now, parallel means these 2 lines will never intersect with each other. There is no common point which lies on these 2 lines. So, therefore, we get the second case where the two lines are parallel, and since they do not intersect at any point, there is no solution. So in the first case, we find that the 2 lines did intersect at one point, and that point of intersection happened to be the solution, happened to be the unique solution. But here in this case, in the second case, the 2 lines are parallel and they would never meet, and hence there is no solution. Let's consider the third case. We have the equation x1 minus 2x2 equals minus 1, and minus x1 plus 2x2 equals 1. Now I have these 2 equations. I observe that the second equation is nothing but the first one, isn't it? If I multiply the whole equation by a minus sign, I get x1 minus 2x2 equals minus 1. So therefore, these 2 lines coincide. If I call this as L1, this is L1 itself, and if I call this as L3, I find that L1 and L3 coincide. So I have L1 and L3. So I find that every point on L1 coincides with every other point on L3. So all the points would form the solution for both the equations L1 and L3. So case 3. Now what is case 3? We find that if the 2 lines coincide, we would have infinitely many solutions. So with these 3 cases, we come to a conclusion, a very important conclusion. What is that? We have a system of linear equations Given a system of linear equations, whether you have a 2-variable linear equation or a 3-variable or an n-variable linear equation, we only have two cases: that the solution exists or the solution does not exist. If the solution exists, we say that the system of linear equations are consistent. If there is no solution for a 2-variable linear equation, no solution means that the two lines are parallel. We say that they are inconsistent. So there is no solution here. But now if the solution exists, then we have two different cases. Now what are they? We could have a unique solution, one solution. That means the solution is unique. Or the other case is infinitely many solutions. So given a system of linear equations, let me again repeat, we have two possibilities. The solution exists. If the solution exists, we say that the system of linear equations are consistent. If there is no solution, then we say that the system of linear equations are inconsistent. There is no solution. So it stops here. Now if the solution exists, that means if they are consistent, then we have two cases. We could have one solution. There could be only a single solution or a unique solution. Or I could have a case where there are infinitely many solutions. So with this we will stop here, and in the next lecture session we shall study what is an augmented matrix, what is a coefficient matrix. So the first thing what has to be done is the linear equations can be represented in the form of a matrix. So how do I represent a system of linear equations in the form of a matrix? And then how do I solve the matrices so that I get the solution? So what are the different ways? So we will be dealing with representing a system of linear equations in the form of a matrix. We shall see what is a coefficient matrix, what is an augmented matrix, and to find the solution we convert the matrix into an echelon form. So we have echelon and reduced echelon form. So we shall see what they are in the next video segment. So do not forget to like, share and subscribe, and press the bell icon to get notifications of all the further other uploads, and thanks for watching.